Southern Ocean, unbelievable and unbearable. Extreme conditions make it one of the worst places to conduct any scientific studies. Now, an Indian expedition will attempt to unravel the mysteries of this ocean. Their mission is to investigate the role and response of the Southern Ocean in the Earth's climatic systems. Early December, a team of scientists embark on a precarious expedition to explore the Indian sector of the Southern Ocean. Their first stop is the island of Mauritius. Here, the team will board the expedition vessel SA Aegis. They're home for the next 2 months. While the crew is busy loading all the scientific cargo, the team is in race against time to set up and secure their labs before they head out on a long voyage. Soon they will be encountering extreme weather and rough conditions. While at port, the bunkering is underway. The team gets a tour of the ship and is also briefed on the safety and emergency protocols on board. With the final checks completed, the ship is given the permissions to embark on the expedition. Their final destination, the Prince Bay area, close to the Indian Antarctic station, Bharati, in the Indian sector of the Southern Ocean. The team will be conducting a series of observations and sample collections all along the course, maintaining the same track as over the last several expeditions. Southern Ocean has an immense influence on the Earth's climatic system. This ocean encompasses the Antarctic continent and connects the Atlantic, Pacific, and the Indian Ocean. It stores and transports more heat and carbon dioxide than any other latitudinal band on Earth. Over the last several decades, the Southern Ocean is undergoing some drastic changes. This has led to an effect on the physical, biological, and biogeochemical parameter of the ocean, affecting the marine ecosystem and the global climate. A meeting is held in order to plan operational sequence of all the instrument at the sampling stations. At the helm of the affairs is the chief scientist, Dr. Rajnikant Mishra, who has a huge task to facilitate and complete all the science objectives.
The major objectives are that it is the study of hydrodynamics and the current of the oceans, how it is play a role, and the transport of mass volume. And the second objective is like that to know that the source of the fresh water and how it is freshening in the Southern Ocean and the Antarctica region with the Antarctica bottom water, and also how it varies from fronts to fronts. We have several fronts in the Southern Ocean.
One of the major tasks during this expedition is to retrieve and redeploy the mooring that was installed last year. This mooring consists of a long anchored line attached with several scientific instruments and floats at various intervals. This setup would give the data with an unprecedented resolution of a year-long changes. that would help the scientists to understand the total carbon flux and the efficiency of the biological pump. With the weather reports indicating of approaching bad weather, Dr. Bhaskar, on consultation with his team and the ship's captain, decides to locate and establish connect with the mooring before the bad weather intensifies.
What is the weather forecast say for tomorrow morning?
This is front coming through the low pressure.
Day after tomorrow it might be better because it's going further down south.
The team lowers a transducer from the aft of the ship, and the series of pings are sent from the deck unit. After repeated attempts, the acoustic releaser attached to the mooring line responds to the pings, giving an approximate distance of over 6,000 meters. The team is thrilled to receive a positive signal.
Finally, the baby is there and she is responding. Right now we received a ping from the instrument which indicates that the instrument is alive. It's able to receive the signal and it's indicating a depth of 6,000 plus meters. So it's a little off from what we have deployed last time, which was around 5,134. What we are trying to ascertain is whether the depth is same, and if it is same, then we need to go closer to the location and identify the new location. Once we do that, we can come back to the same spot before the retrieval of the mooring.
As expected, the weather worsens and a decision is taken to abort the retrieval process due to high sea state and rains, hampering the visibility. Early next day, the weather settles in. The team takes a stock of the situation and decides to go ahead with the retrieval process.
We are bringing it.
You know when you release it.
Okay.
An attempt is made to re-establish the connect between the mooring and deck unit.
Yeah, Michelle.
We tried pinging it again, but it's showing some error values as before. But I think we already got one location, one value which is fair enough. So what do you prefer? Should we release it now?
Let's take a calculated risk and we can release it.
Come again?
Let's take a calculated risk, we'll release it.
Okay.
On receiving the necessary signals, Dr. Bhaskar gives a go-ahead to initiate the release. Once the command is given, the acoustic releaser detaches from the dead weights, and with the help of the floats and the buoy, the mooring assembly is expected to surface up in about 5 to 10 minutes.
The deck, the buoy has been released. Watch out for the buoy.
The entire team, along with the ship crew, are now spread across the ship in anticipation for the sighting of the buoy. It's a nerve-wracking moment for the entire team, as once they retrieve the mooring, it would give them the data of a year-long changes that has happened in this area of the Southern Ocean. It's been over 20 minutes after initiating the release command. The team is yet to sight the buoy. Repeated attempts are made over the next several hours to ping and locate the buoy, which kept indicating a distance of around 6,000 meters from the ship. After spending more than 48 hours at the mooring site, the team calls off the operations. They speculate that the mooring is still attached to the weights and probably there has been a malfunction with the acoustic releaser that is still anchoring the mooring line. The team will now have to devise an alternate strategy to bring the setup out during the return leg of the expedition. Southern Ocean has a reputation of being one of the fiercest ocean. Here, the weather can change dramatically without any warning. No wonder many who have braved to sail in these waters have described these latitudes as roaring 40s and furious 50s. Several team members are already feeling the brunt of the rough sea conditions. The ship doctor, Dr. Zoel Halowitz, takes the job very seriously and keeps a stock of the situation. She realizes that if there is a situation on board, getting help would be extremely difficult. Despite the ship moving through rough waters, the life on board goes on. And a well-staffed galley caters to those who can manage to keep their food appetite. Over the next few weeks, the team will stop at several multidisciplinary stations. Here, the team will operate several scientific instruments that would help them not just collect samples but also monitor ocean and atmospheric parameters. One of the main equipment on board is the CTD rosette that would be extensively used at all the sampling stations.
This is a CTD. It stands for conductivity, temperature and depth. These are the main parameters which it measures. It is an integral part of the ocean observations. From this, you can see over here, this is the CTD unit. It has a pump, and in addition to that there are temperature and conductivity sensors. The accessory sensors that are present on this unit, we have dissolved oxygen. There is an instrument for measuring the photosynthetically active radiation. There is a sensor which measures fluorescence and turbidity. This entire thing is called CTD rosette. So there are like 12 bottles mounted on this. These bottles are called as Niskin samplers, and these samplers are used to collect water samples from different depths. So the scientists check out the temperature salinity profiles while the CTD is going down, that is with respect to depth, and based on their interest, different bottles are fired at different depths.
The CTD unit is lowered down using a winch to a desired depth. While it is being retrieved back, an electronic signal from the deck unit triggers these bottles to capture water as per the depth required. Once the unit is safely secured back on the deck, scientists rush into siphon of the water and take it to their respective labs to carry out further analysis. Once the CTD operations are completed, the team now shifts operations towards biological sampling. The team uses several types of nets that will collect organisms ranging from phytoplanktons, zooplanktons, larvae, krill, and even small fishes. A multiplankton net is used to profile the water column vertically. The MPN contains a series of nets that are opened by a trigger from the deck unit at certain depth. At the end of each net is a bucket that collects all the trapped organisms. While the other nets, the bongo and the IKMT, profile the waters horizontally on the surface or at a particular depth, with the ship dragging these nets at a constant speed. The organisms trapped in these nets are then hauled back to the ship, where they are collected and taken to the labs. Dr. Ravidas Naik examines these samples for phytoplankton diversity through which he plans to understand their response to changing climate.
Phytoplankton, there's the microscopic organisms, which serves as a food, the base for the entire marine food web, and whatever happens, any region, when we talk about a global climate or any climatic variations. So if there is any variations, so these organisms will be the first one to give a response, being like, because as I said, they are the base for the food chain. So anything happens to this organism, and their response can, by studying their response, you can correlate with the higher level. And that's the reason, like, the study of this particular organism is important from area like Southern Ocean.
At the aft of the ship, the scientists are now getting ready to carry out bio-optical measurements. They use specialized instruments to understand the effect of the biological processes on the optical properties of the ocean waters. The ocean's spectral characteristics are modified by dissolved and suspended substances, and in order to get a global picture, scientists make use of satellite images. To validate these images, it is imperative to make in situ measurements that would help correlate the ocean spectral signatures to the satellite data. The team lowers a set of instruments one after another. These include a fast repetition rate fluorometry, inherent optical profiler, and hyperspectral radiometer. These instruments measure several ocean parameters that are then correlated with the satellite data to get a holistic understanding of the Southern Ocean. Back in the lab, Dr. Sarat Tripathi and his team is using the sampled water from the CTD rosette to conduct an interesting research in understanding on how the primary productivity varies with respect to the changing physiochemical and bio-optical environment in the ocean.
So what is primary production? The rate at which phytoplankton convert the inorganic matter such as carbon dioxide, nutrients to organic material at the presence of sunlight is called primary production. And to measure this activity, we collect samples from discrete depths in the water column. We enrich them with carbon-13 or carbon-14 isotopes and incubate them by simulating the light conditions and temperature conditions. And after 24 hours, we filter the samples to be taken into the soil laboratory where we can measure the carbon taken by the phytoplankton.
He injects the water samples with the carbon-13 and carbon-14 isotopes separately. The water samples are then stored in specially designed incubation bags that stimulate the light conditions in the euphotic zone. These bags are then immersed into the tank for a period for 24 hours and is then analyzed to estimate the rate of primary production. The team also uses a spectrophotometer in order to understand the influence of the bio-optical parameters by measuring the absorption of light by phytoplanktons and other dissolved particles in these waters. While in the other lab, Dr. Shramik Patil is busy filtering water collected during the CTD cast, as well as the surface waters that he has been collecting every 6 hours since the start of the expedition. They run the water through the filtration units to filter out coccolithophores and diatoms. Coccolithophores are tiny plant-like organisms that are made out of a single cell and are plated with calcite mineral. These coccolithophores play a critical role in regulating the global carbon cycle. After more than 18 days sailing through turbulent conditions, the ship has now reached the calmer waters of the Southern Ocean. Every year, as the sun disappears for the winter, the surface waters around Antarctica freeze into a slab of ice, effectively doubling the size of the continent. During summers, the slab of ice breaks into pack ice fragments, which eventually drifts out to the sea and melts. The team gets excited to spot its first iceberg, a free-floating chunk of ice carved out of ice shelf. These majestic icebergs reveals only 1/8 of itself, drifting silently and menacingly through these waters. The ship is now at 66 degrees south. Here, the team will carry out yet another important operation of coring into the ocean floor to retrieve sediments. These sediment layers are like a time capsule locked with vital information of the past ocean and climatic conditions. During a previous attempt, the team had suffered a major setback when the coring cable snapped during the retrieval process. The corer was lost to the ocean. The engineers were quick to rebuild the corer in a couple of days with the spares available on board and are here today for another attempt. If they succeed, it would indeed be a great achievement of retrieving a core from the depths of the Southern Ocean, as it's extremely difficult owing to the rough seas and hazardous conditions. 2.5 hours into the operations, excitement looms on the team while the corer is being retrieved back onto the ship. Nobody knows if the newly built corer would have the sediments trapped in it. With the corer back on the deck, Mr. Bhupati, the engineer who was instrumental in building this coring rig, unscrews the core catcher. He is excited to see the sediment core trapped in the corer. While the team cuts the core into a meter-long section and stores them into the -20 degrees Celsius reefer, Dr. Anup Mahajan, who has been a part of several ocean expeditions before, is on this cruise to understand the complexities of ocean atmosphere interaction. He is interested in studying the chemistry of the atmospheric marine boundary layer, especially with regards to the role played by halogens.
So basically, if you think about the impact of the ocean on the atmosphere, especially in the Southern Ocean, you can broadly categorize it into two parts. One is, it's called energy exchange, so something like heat would be exchanged between the ocean and the atmosphere. And the other one is mass exchange. So you get gases and particles coming out of the ocean, or the other way around, from the atmosphere into the ocean. Most of the activity we are doing during SOE 10 are in the second half. So basically, we're working on mass exchange. So for example, we are measuring different types of gases. May they be oxidants or leading to new particle formation, or it can also be emission of aerosols from the ocean surface itself. Within this, there are 4-5 different institutions involved. Some institutions are focusing on gas exchange, the others are focusing on aerosol exchange. We have different types of instruments on board. This particular one is called the Multi-Axis Differential Optical Absorption Spectrometer, or MAXDOAS for short. And what it does is very simple. It has a tiny little prism which acts as a mirror, and all it does is it starts looking for light along a certain line. It will look for light along the horizon and then start changing its angle until it reaches the zenith. So basically what it's measuring is the scattered sunlight from every different direction going from the horizon to the zenith.
While another team is gearing up to launch the radio sonde from the upper deck, Dr. Shrivardhan Hulswar and his team have been launching these balloons at every degree latitude interval.
Okay, these are the payloads that will go up with the balloon. This is the temperature sensor, this is the humidity sensor, and this is a GPS module and a battery that can last for around 7-8 hours. in this thing. And this is the antenna through which it will communicate on 403.5 megahertz. So right now we need to activate the sensor first.
These balloons reach to a height of about 35 kilometers and transmit the data to the receiver on the ship on a real-time basis. Safety in these ice-clogged waters means constant vigilance. The expedition ship aegis is an ice-threatened vessel and not an icebreaker. This 40-year-old ship has been on several expeditions to the Antarctic before and is no stranger to these conditions. Captain Michael Barnes navigates these waters knowing others have attempted and failed. He follows a simple rule: never underestimate the ice. Satellite ice charts and reports have shown a huge concentration of pack ice around the Prince Bay area, hampering the science objectives.
This is the map of the entire Antarctic region with the ice shown in colour. And this is a blow-up of where we were trying to get through. Unfortunately, we couldn't get through. There was just a little bit too much ice.
The chief scientist is updated about the conditions. He calls for a meeting to discuss the alternate locations for sampling.
Captain said that it is not possible. We tried to enter, but it's a difficulty. If we'll enter and then if it will be thick again, then we will not come out from that. So that's why now the new revised track would be like this 65, 30. Means this line we have to catch it.
The team decides to move to the open waters, potentially free from pack ice, to conduct a 3 days long time series observations. Here, the team will spend around 72 hours at a single location, conducting a series of observations in physical, chemical, biogeochemical and atmospheric observations at every 8 hours interval.
Time series observations are a series of observations that we make at any one location based on the objectives of the study that we want to carry out. So basically, it's a study to understand the temporal differences over a short period of time. It could be a couple of days to a couple of weeks, depending upon the nature of experiment that we are trying to address or nature of objective that we are trying to address.
48 hours into observation, there is an announcement on the PA systems of whale sighting on the port side. Over the last few days, the team has sighted several whales, but have always been disappointed as they never got to see it in its full glory. Their luck is about to change, as one of the juvenile minke whale approaches in close proximity to the ship. The team is delighted to get a spectacular view of this minke whale. It's New Year's Eve. After 21 days of sailing and conducting several science operations, the team takes out time to celebrate the event. The ship's captain throws a barbecue party. A new year that would be cherished by all for the rest of their life. After a night long of partying, it's now back to business. Dr. Sabu and his team has been deploying several instruments to understand the Antarctic circumpolar currents. These oceanic currents flows from west to east around Antarctica. These currents play a crucial role in global ocean circulation and transports heat and vast amount of nutrients across the ocean. The team has been using several instruments to record various parameters like conductivity, temperature, and salinity profiles using the XCTD and UCTD instruments. They study the mixing and turbulence in the ocean by using a microstructure profiler, and for direct velocity measurements they use the lowering acoustic Doppler current profiler. Navigating through these icy waters is a challenge, and at the heart of the operation is the engine room that has been constantly running from the time the ship embarked on the voyage. The engine is powerful enough to propel the ship at a top speed of 14 knots for over 90 days at a single stretch. After carrying out majority of scientific operations in the Antarctic waters, the team has now started the return leg. Sighting of icebergs have now reduced and the waters are no longer calmer. As the ship heads back, the captain gets updates of an approaching cyclonic storm. While he charts a course to avoid the storm, the weather deteriorates. Heavy snowfall has now covered the ship's deck, effectively warning of the hazardous conditions ahead. The captain puts the team on high alert and advises them to stay indoors. All scientific operations are now put on hold. After almost 2 days of intense rolling and pitching, the storm has now subsided. The team takes a stock of the situation only to realize some of the damages done by the storm. Apparently, one of the boxes in the cargo hold got loose during the stormy weather and ended up creating a tsunami of destruction. It was by sheer luck that none of their instruments were damaged or destroyed except for a few unused sampling bottles. Storms like these only explain the extreme difficulties and challenges of conducting any scientific studies in these waters. A clever way of carrying out observations in these waters is by deploying a specialized float known as the Argo. Argo, or Array of Real-Time Geostrophic Oceanography, is an international program that uses profiling floats to monitor the oceans around the world through the year. Dr. Isabella Rosso has been deploying several such floats during the expedition. Today, she is all set to deploy the last one.
We're going to deploy a biogeochemical float, which is part of the SOCOM project, the Southern Ocean Climate and Carbon Observations and Modeling Project. So this is like an Argo float. It is equipped with a CTD sensor and an antenna to send the data via satellite. And then it has also some biochemical sensors like the fluorometer and backscatter, nitrate and oxygen and pH. So like a normal float, it will descend to 1,000 meters and it will drift at 1,000 meters for 10 days. After which it will descend to 2,000 meters and then it will profile up to the surface, sending the data via the antenna on the top. And then it will repeat the cycle.
These floats have played an instrumental role in increasing our understanding of the oceans, as the data have helped the scientists comprehend the seasonal changes in the ocean. It's 26th January, the Indian Republic Day. The chief scientist hoists the Indian flag with the team proudly singing the national anthem. A small celebration marks the event. Later that night, Saji Kumar and Ragesh are on this voyage to study the abundance of the cephalopod in the Southern Ocean. They are interested in a particular type of cephalopods, squid. These cephalopods play a key role in many marine ecosystems as a predator and at times as prey, and represent one of the most important commercial marine resources. The duo have been squid jigging for the past few days, hoping to catch squids. Today, they are happy to have caught several squids, which they would be analyzing in detail once back to their lab in India. The team is now heading to the end of their expedition and are approaching the 40 degrees south latitude. They now have one last scientific operation before they head back home, and that is to try another attempt to retrieve the mooring. With failed attempts at the start of the expedition, the team is now desperate to try an alternate methods to see if they can recover the mooring out of the water. They decide to lower a long cable with anchor hooks attached at different intervals, while the ship tows it with a constant speed following a designated path. They hope that the hook would get entangled with the mooring line and gets pulled out of the water. Unfortunately, after several attempts, there is no trace of the mooring line. The team is extremely disappointed as they have worked hard over the last few years in designing and assembling the mooring. After almost 57 days of sailing through one of the toughest ocean, the Mauritian coast is now in sight. It's a happy feeling for the entire team who were away from civilization for the past 2 months on a voyage of potential discoveries and challenges. Excitement grips as the team spots the Port Louis harbour. It's 5 p.m. The ship has been waiting at the outer anchorage for more than 6 hours now. They are yet to receive the permission from the port authority to enter into the port.
Control, this is the aegis calling channel 16 over.
This is aegis for control 14.
Channel 14. Control, this is the aegis calling channel 14 over.
This is aegis for control.
Good afternoon, once again, sir. Just to report that we are 3 miles away from the pilot station, waiting for further instructions.
Okay, so for information, maybe pilots are around 7:45, 1745, something like that.
While the team waits, they are overwhelmed to see one of the biggest cruise liners, the Queen Mary 2, leaving the port. With the berth now empty, the ship finally gets the green. The port pilot is now on board to take charge of the ship and slowly navigate to its allotted berth. The ship is now docked at the port and the gangway is lowered. The team finally sets foot on land after almost 2 months at sea. The next day, with the expedition almost over, the team now has a Herculean task to secure their cargo and pack their samples before they're sent to the National Center for Polar and Ocean Research. Although the expedition has ended, the real work is just about to begin. The team will now need to analyze the data that they have gathered over the voyage that would help them decode the mysteries of the Southern Ocean.